Today, we're taking something we all learned back in grade school, fractions, but we're going to look at it through a completely different, almost philosophical lens. We're unpacking this beautiful guru-disciple story, specifically a fascinating teacher's fraction lesson that reveals the hidden origins of how we actually name mathematical concepts. It's not just numbers on a chalkboard, you know? It's a story about logic, language, and literally pushing the boundaries of what we know. So let's get into it. Think about it. We usually just memorize math terms, like improper fractions, without ever really stopping to wonder where these words came from. Why improper? Did someone just pull that word out of thin air? Well, this brilliant narrative asks us to consider how logical paradoxes actually force our language to expand. It shows us that vocabulary isn't just random, it's a direct, necessary response to a mathematical crisis. So, what exactly are fractions? The quest for knowledge in our story begins right there, exactly where you'd expect, with a simple, foundational question from the first student. This student looks at the guru and basically asks to define what a fraction fundamentally is. The student just wants to know the true basic nature of these numbers. The guru expertly answers by explaining that a fraction is, at its core, just a part of a whole. He uses a really clear example. Imagine you have a pie and you cut it into 4 equal slices. That 4 is your complete whole. If you take 3 of those slices, you get 3/4. Makes sense, right? It fits perfectly within our everyday understanding of reality. You have a whole, you take a piece of it, and it is, by all definitions, totally proper and expected. But wow, this is where the teacher's lesson takes a truly fascinating turn. What actually happens when human curiosity pushes past those neatly established boundaries? Once these students understand that a fraction is just a piece of a whole, their minds naturally start testing the limits of that very definition. They start pushing the limits of logic itself, venturing out into this wild territory where the old rules suddenly just don't apply anymore. And that brings us to the second student, who suddenly hits this logical roadblock, a real paradox. They look up at the guru and ask, wait, if a fraction is a part of a whole, can 4/3 also be considered a fraction? Seriously, think about that for a second. If the whole only has 3 parts to begin with, how on earth can you possibly have 4 of them? This student has essentially broken the system. They've stumbled upon a number that mathematically exists, but conceptually completely contradicts the very definition they literally just learned. Now, the guru doesn't just dismiss this. Instead, he uses pure logic to tackle the paradox head-on. He explains that 4/3 just cannot be understood merely as a part. Why? Because it's actually larger than the whole itself. If the whole is 3 and you somehow have 4, you've completely overflowed the container. Because of that, making it a simple part is impossible, and it feels entirely inappropriate to call it an ordinary fraction. The traditional, safe definition has officially broken down. This is exactly where the genius of the teacher's fraction lesson shines. How does the guru handle this breakdown? He drops this timeless piece of wisdom. Necessity is the mother of invention. It is such a fantastic teaching moment. He's telling his students, look, you haven't made a mistake here, you've made a real discovery. When we hit a totally new concept that just shatters our existing frameworks, we are literally forced to invent a completely new way to describe it. And this perfectly sets up the third student's dilemma. The whole classroom has now accepted that this impossible number exists, right? And they accept it can't be an ordinary fraction. So jumping to the next logical step, the third student asks the million-dollar question. So what do we call it? If it isn't a normal fraction, what is it? Suddenly, our language is coming up completely empty. We just don't have the words to describe this mathematical reality. And you know, this brilliantly illustrates the core rule that we still use today. It gives us a super clear comparison. When the top number, the numerator, is smaller than the bottom number, the denominator, it fits neatly inside the whole. It behaves itself, it is a proper fraction. But the second it breaks that boundary, if that numerator overflows and gets larger than the denominator, it breaks all the rules. It immediately becomes an improper fraction. So, looking back at this entire exchange, the takeaways from the teacher's fraction lesson are actually pretty profound. First off, mathematical ideas are always going to cross established boundaries as human curiosity explores them. That's just what we do. Second, when that inevitably happens, our language physically has to expand to match those wild new ideas. And third, which I honestly think is the coolest part, vocabulary is born from pure logical necessity, not just arbitrarily. Words like improper weren't just made up for the fun of it. They were absolutely required to explain a truth that had completely outgrown its old definitions. The whole idea that language expands purely out of logical necessity is just a fascinating way to look at the subjects we study every single day. It gives so much more weight and meaning to the terms we throw around. As we wrap up this explainer, I want to leave you with one final provocative thought. Think about the terms we use in math, in science, or even just in everyday life. Does language always naturally follow necessity, or do we sometimes end up trapping our own thinking within the boundaries of the words we already have? Do you agree with the guru's logic? Definitely something to chew on the next time you encounter a word that seems just a little bit out of place.